சொல்லு. Lower to higher is the flow of negative charges. Electron will flow from lower to higher. இவனா கத்துறதா? Those are online. Are you able to hear me?
Yes, sir.
Okay. Right? Yes. So we'll go to the next concept, that is cells in series. Right? So we understood that when a cell is there, how do we calculate the relation between the terminal potential difference, EMF, and the internal resistance, right? So we saw it for two conditions, that is discharging and charging. So today we are going to understand the concept of cells in series. Okay. So we'll be seeing for cells in series. So as mentioned previously, right, we already know this. So you take a positive terminal and a negative terminal if they both are connected in this way. If the positive of the first one is connected to the negative of the second, then you call it as series connection. But if you connect it in the reverse also, you can still call it as series connection. So like how we saw the concepts with respect to the passive elements like resistors, capacitors, right? For resistor, what did we say? If they are connected in series, then the current flowing through them is going to be same, whereas the potential difference will get divided. Right. So wherever you see the word wherever you see the word series or parallel, there are only two parameters that come into picture: current and voltage. So if it is resistor, it is current and voltage. If it is a capacitor, charge and voltage. Similarly, we'll be seeing something called as inductor in the 6th chapter. At that point, we'll discuss about it. Okay. So here what we are going to do is the passive elements are replaced with active elements. What do you mean by passive elements? The one which extracts energy, like resistors, capacitors, right? What are active elements? The ones which supply energy. Can you give me examples of active elements? Battery, cell. Also a charged capacitor. So if you have a capacitor which is charged, it can act as an active element because it can supply energy to the neighboring materials. Is that point clear? Right. Now, when I say this, first let's observe what happens diagrammatically. So if I take this to be E1 and this to be E2, now listen to this. There are two cells connected in such a way that E1 is supplying current. E2 is also supplying current, right? They are supplying in such a way that the currents are complementing each other. That is, they are supporting each other. So let's say if E1 releases current I1 and E2 releases current I2, what will be the net effect? It will be I1 plus I2, which I will call it as I itself. Am I clear with this? Right. So if I take this point to be A, this is B, and if I take this point to be C, what I need to do is I need to replace these two cells and these two cells with internal resistance with a new cell and internal resistance, which I call it as E equivalent, and here you will call it as R equivalent, which I will take it between A to C. Is that point clear? Right. Now, what should this cell do is it should supply the same net current I. So not one thing not to get confused is it is not I plus I, which is 2I. It is the same current I that is flowing through both the cells. Is that clear? So if I apply the relation for the terminal potential difference and EMF for the first cell, can I write VA minus VB is equal to E1 minus I into R1? V is equal to E minus IR in the case of discharge. Similarly, VB minus VC is equal to VB minus VC is equal to E2 minus I into R2. Makes sense? Right. Now, between the points A and C, I have this. So here what I will do is I'll write VA minus VC is equal to E equivalent minus I into R equivalent. Is the point here? No. Since I need for VA minus VC, what I will do here is I will add them. When I add them, VB and VB will get cancelled. I'll get VA minus VC is equal to E1 plus E2 minus I into R1 plus R2, which I'll call it as equation number 1, and let this be equation number 2. So if you observe in 1 and 2, VA minus VC can be replaced with E equivalent minus I into R equivalent. I'll substitute it here. So E equivalent minus I into R equivalent is equal to, can I write this as E1 plus E2 minus I into R1 plus R2? Right. So what is E equivalent equal to? It will be E1 plus E2, and R equivalent will be equal to R1 plus R2. So it is obvious, irrespective of however the cells are connected, if you take the resistors and connect them in series, they get added up. That's what is happening here. Clear? So this is all about the cells in series. But one more point I would like to mention here is if there are n cells that are connected in series, then what will happen to the value of E equivalent? If the n cells are connected in such a way that the unlike poles are connected, means the negative of first is connected to the positive of second, when you take them into consideration, E equivalent will be equal to E1 plus E2 plus so on till En. And what will be the value of R equivalent? Obviously, R1 plus R2 plus so on till Rn. That's it. Right? So make a note of this. Current will be negative. அது when you apply Kirchhoff's law மட்டும் தான் அதை பார்ப்போம். இங்க எதுவும் பண்ண மாட்டேன். ஏன்னா discharge ஆகுது. When current is away from the positive terminal, when current is away from positive terminal, it is minus. Towards positive terminal, it is plus. Let me know once you're done copying. Listen. So, another important note that needs to be made is, see, if the cells are connected in such a way that the like poles are connected together, the negative is connected to negative, then what will happen is, let's say this is 5 volt and let's say this is 3 volt, then the net EMF in this scenario will not be equal to 5 plus 3, rather it will be 5 minus 3, which will only be 2 volt. Though they are connected in series, how did I say they will be in series? Because the same amount of current is going to go through. Though they are connected in series, what will happen is the EMFs will get subtracted. Okay, so this is one such situation you will face it in two problems. Is the point clear? So you can make a note of this point, make it quick. This is I1, this is I2. They both are flowing in opposite direction. They're counterparts. The I1, I2, you write it as I only. Actually, in the problem solve பண்ணும்போது, you will write only I in this direction. You will not write this. Because in which direction will the net current move? More side. Here. So listen. So let us do a problem that is based on cells in series. Okay. So from the given circuit, find the equivalent EMF of the combination. So it's very simple. See, there are 4 9-volt batteries which are connected across each other in such a way that the unlike poles are connected. Whenever the unlike poles are connected, they always get added up. So here, how much will be the answer? It will be 4 into 9, which is going to be 36 volt. What about the equivalent internal resistance? Irrespective of howsoever the batteries are connected or the cells are connected, their internal resistance will always get added. So 4 into 0.1 will be 0.4 ohm. What about the total current that is flowing through the circuit? So to find the total current, what I'll do is I'll redraw the circuit. Observe. So I'll redraw the circuit in such a way that I can replace the 4 9-volt batteries with a 36-volt battery. Right? I'll replace it with a 36-volt battery whose internal resistance is 0.4 ohm. Am I right? So internal resistance is 0.4 ohm, which is connected across a 10 ohm battery. Sorry, 10 ohm resistor. Now, this 0.4 and 10 can be treated as series connection, right? So, how will the equivalent circuit look like? It will be 36 volt connected across 10.4 ohm. So, what is going to be the value of current? I will be equal to V by R. So, 36 divided by 10.4 ampere. Is that clear? So 36 divided by 10.4 ampere is what is going to be the value of current. That is the total current. Now, the next question they are asking is, what is the potential difference across the external resistor? Right? So this is the external resistor. Across the external resistor, whatever is going to be the terminal whatever is going to be the potential difference, it will be the same value as that of the terminal potential difference across the cell. So there are two ways to understand it. What I can do is I can directly apply V is equal to IR. So V is equal to IR, how much will it be? 36 divided by 10.4 into R is 10. So basically it is 360 divided by 10.4 volt. That is one way. Or else the alternate way is, just to give you a different perspective, okay, I can find the terminal potential difference here. So what is going to be the terminal potential difference? It will be E minus I into R. What is the value of E? 36 minus I is 36 divided by 10.4 into R is 0.4. So when you solve this, you will get the same answer. So basically you take out 36, right? If you take out 36, what you will get is 10.4 minus 0.4, the whole divided by 10.4. So it will be 10, 36 into 10 is same 360 divided by 10. Both are same. Okay. So make a note of this. So make a note of the diagram also. Shall we proceed? Those who are online are able to understand?
Yes, sir.
Yes, sir.
Okay. So the next question, sorry. So the next topic that we are going to see is cells in parallel. So whenever we speak about parallel connection, what is going to be the same value? It is going to be the potential difference, right? So when I take one cell like this and another cell like this, whose values are E1 R1 and E2 R2. So if I take the external resistance here as capital R, then this is going to supply current I1, this is going to supply current I2, right? And let's say that the net current here is going to be I. Okay, that capital R is connected only for us to understand that they are in parallel. You're able to understand that the current gets divided. So what is happening in the parallel connection? Voltage wise it is same, current wise they get split and added. So they get split and then added to give you the final value. Is that right? No. The question is, if I take this to be AB, if I take this to be CD, okay, what is VA minus VB? So VA minus VB is going to be equal to E1 minus I1 R1. It's going to be E1 minus I1 R1. So what about VC minus VD? It will be E2 minus I2 R. Right? It will be E2 minus I2 into R2. But the point to be noted here is VA minus VB is exactly the same as VC minus VD. Why is it so? Because they are in parallel, right? So if I call this potential to be V, if I call it to be V, then VC minus VD also can be called as V only, right? Now from the first statement, what I will do is I will take this part alone. When I take this part, if I do the rearrangement, as E1 minus V is equal to I1 into R1 will go to the other side. So what is the value of I1? E1 minus V divided by R1. Let me call this as 1. Similarly, if I take the second and do the same kind of rearrangement, then I'll get E2 minus V is equal to I2 R2, which implies I2 is equal to E2 minus V divided by R2. Let this be equation number 2. Am I clear with this? Now, if I redraw the circuit into an equivalent one, what do I mean by equivalent? I need to replace these two cells with one cell whose effective value is E equivalent and R will be R equivalent connected across the same resistor capital R, and this cell is going to supply the total current of I1 and I2. So which is going to be the same I here. Am I clear with this? Now listen to this carefully. If I take this to be E and if I take this to be F, right? Then what is VE minus VF? It will be, so if I take this point to be E and this point to be F, okay. Then this will also be E and F. Right? Okay. One correction. It's not correction basically, just to give you more clarity. So forget about this E and F. I'm taking E and F here. Okay. Then what is going to be VE minus VF? It will be E equivalent minus I into R equivalent. But the important point to be noted here is VE minus VF will also be V. It will also be B. So again, I'm going to do the same kind of rearrangement. When I do that, I get E equivalent minus V divided by R equivalent is equal to I. So let me call this as equation number 3. Now listen to this step. What is the relation between I1, I2 and I? I1 plus I2 is equal to I. So first equation plus second equation is equal to third equation. Right? So we know that I1 plus I2 is equal to I, or I can write it in the reverse also. Right? What is the value of I1? E1. Now what I will do is, this is E1 minus V by R1. No, I will split this R1 to each term. It will be E1 by R1 minus V by R1. So E1 by R1 minus V divided by R1 plus E2 by R2 minus V divided by R2. This whole thing will be equal to E equivalent by R equivalent minus V divided by R equivalent. Am I clear with this? So combine E1 by R1 and E2 by R2. So E1 by R1 plus E2 by R2 minus, I'll take out V common. You will be left out with 1 by R1 plus 1 by R2 is equal to E equivalent by R equivalent minus V into 1 divided by R equivalent. So when you do the comparison on both the sides, E equivalent by R equivalent will be equal to E1 by R1 plus E2 by R2. Similarly, 1 by R1 plus 1 by R2 will be equal to 1 by R equivalent. So this is what happens in parallel connection. So when you connect the cells in parallel, this is what you need to remember. Unlike the case of cells in series, you're not going to get a simple expression. So even if you want to find the equivalent EMF in the case of parallel, you need to find the value of R equivalent. Are you able to understand? So this is how the cells in parallel will work. Now, what if I extend it to n cells? It's obvious. E equivalent by R equivalent will be E1 by R1 plus E2 by R2, so on till En by Rn. Similarly, 1 by R1 plus 1 by R2 will be equal plus 1 by Rn will be equal to the value of 1 by R equivalent. Clear? So make a note of this. V equivalent is any value illa. R equivalent into R equivalent and the pakam bodu. Another one. If you want to find the equivalent, series la panadari panna. Just add them or subtract. So keep solving this problem. So now let us see a problem that is based on cells in parallel. So from the given circuit, find equivalent EMF, internal resistance, that is the equivalent internal resistance, total current, potential difference across the cell, current from each cell. Okay. So when I talk about equivalent EMF, right, the first thing is whenever you need the equivalent EMF in parallel, you always first need to know the equivalent resistance. So what is 1 by R equivalent in this case? It is all the 4 resistors are of the same value. So it will be 4 divided by 0.5. Why is it so? Because 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So 4 divided by 0.5 will be 8, which implies R equivalent will be equal to 1 by 8 ohm. Okay, it is equal to 1 by 8 ohm. This is the value for equivalent internal resistance. Now, what is E equivalent divided by R equivalent? It is going to be E1 by R1 plus E2 by R2 plus E3 by R3 plus E4 by R4. It's very simple. So E1, E2, E3, E4 in this case is 5. And R1, R2, R3, R4 in this case is 0.5. So you will have 4 times 5 divided by 0.5. See, 5 divided by 0.5 is going to be 10. So 10 into 4 is going to be 40. This is going to be the value of E equivalent divided by R equivalent. So what is the value of R equivalent if you go to the other side? You have 1 by 8. No, if you go to the other side. So E equivalent will be equal to 40 into 1 divided by R equivalent. 1 by R equivalent is how much? 8. Yeah, 1 by R equivalent is going to be 8. So it will have a value of 320 R. It's not possible. Sorry? In the fighter. Actually, it can't be greater than that value. It should go as R equivalent. There is a mistake. Sorry, guys. Correction. Listen. You understood what is the mistake? I took this side as 1 by R equivalent. Yeah. Anyways, correction. Listen. So E equivalent will be equal to 40 into R equivalent. So 40 into 1 by 8, which is equal to 5 volt. Meaning you can replace all this with the same 5 volt battery, right? So this is the equivalent EMF. What about the total current? Why is it 4 by 5.0 point? Why is it 5 by 4 point? That is cell and internal resistance. So that's not how you don't know. What about the terminal potential difference across the cell? So even before that, I'll tell you that is not going to be, you should not take it as 5 by 0.5. Listen to this carefully. This whole system of cells, can I redraw it and write it as a 5 volt battery having an internal resistance of 1 by 8 is connected across a resistor of 10 ohm. Did you understand what I did? All these 5 is replaced with 1 5. What is R equivalent? 1 by 8. So 10 ohm is already existing. Now you solve this. This 10 and 1 by 8 are in series. So what is going to be the equivalent resistance? So this will be 5 volt. What is going to be the equivalent resistance? It will be 81 by 8. It will be 81 by 8. Right. So now you apply V is equal to IR. Now when you apply V is equal to IR, for this part, if you apply V is equal to IR, V is how much? 5 is equal to I into R is 81 by 8. So I will be equal to 40 divided by 81 ampere. So it is 40 divided by 81 ampere. This is the total current supplied by the battery. Now, see, this is the total current. They're asking the potential difference across each cell. But for me to find the potential difference across each cell, first I need to know the current from each cell. Okay. See, if the total current supplied by the system is 40 by 81, observe all the cells are identical here. Then what is going to be the current across each cell? It will be the total current supplied divided by 4. So what is the answer going to be? It will be 10 divided by 81 ampere. Am I clear with this? It will be 10 divided by 81 ampere. 4 cells, right? These 4 cells put together is supplying a current of 40 by 81. So how much will each cell supply? Since everything is identical, 40 by 81 by 4. It is 10 by 81. Clear? So this is the answer for the 5th part of the question. But what about the 4th one? What is the potential difference across each cell? So for potential difference across each cell, we'll have V is equal to E minus I into small r. So E is how much? 5 minus I is 10 by 81 into what is the value of small r? It is half. Cancel. So it will be, if I take out 5 common and I'll get 1 minus 1 by 81. So 5 into 80 divided by 81 is what I'll get. And the answer will be 400 divided by 81. 400 divided by 81 volt. See, 400 by 81 is less than 5. Because we know, right, in the case of discharging, the EMF will always be greater than. EMF will be greater than the terminal potential difference. So EMF is 5 means the terminal potential difference should be less than. Okay. So make a note of this. Logical issue. Smaller on the case 1 by 8. அது பண்ணும் parallel R by N. அது கூட. But that formula itself has come only because of that logic. Did you all understand? Okay. See, there are two important concepts left out. One is electrical power, okay, and the second is Wheatstone bridge. I'm going to explain electrical power. So the next concept we are going to discuss is electrical power, for which, if you look at the definition, it is defined like this. It refers to the rate at which electrical energy is transferred or converted. For example, if you take the fan into consideration, when you switch it on, electrical energy is getting converted to mechanical energy. Similarly, when you think of light, right, electrical energy is getting converted to light and heat energy, right? So the rate at which this is happening is what we call it as power. That is why when you go to a shop, right, like when you try to buy any electrical equipment, I say any electrical equipment, for example, you take this fan, you take tube light, you take AC, you take a mixer grinder, whatever is the electrical item where you're directly plugging in into the system and using it, it will have a power rating associated. So what is the meaning of that power rating is? That is the amount of power it needs to perform the task, to put it simple. Okay. And secondly, there will also be a rating that will be given in terms of potential difference. What is the potential difference across which that particular electrical equipment can work? For example, some will be designed only for India, some will be designed for some other country. That is why if you see, it will vary. Whenever you travel or you need to go to some other place, let's say you're traveling to some place, you don't like the food there, you want to carry your rice cooker. Then the first thing that you need to check is what is the power rating there. Only then you will know whether the device that you have at home will be useful there or not. Or else what will happen, you will all the way take it, suddenly you will plug it, nothing will work. Or it will blast also, who knows. For example, our power, the power at which we can use is, let's say, 110 volt, okay, which happens in US. If you suddenly bring it here and you try to use it, you're trying to supply more amount of energy, it might blast. It varies. So what you need is a transformer to convert it, about which we'll learn later. Okay, so just to come back to the concept, there is something called as power rating. Next time onwards, observe it. Okay, so let's come back to the theory of what the power rating is. To put it simple, I'm talking about electrical power. So power is basically the rate of doing work. The rate at which you're going to do work is what is called as power. So amount of work done per unit time. But we know that whenever you do a work, in the case of an electrical system, it will get stored in the form of electrostatic potential energy, which is also written as Q into V. And the T is T itself. So what is this Q by T called as? So you can call it as I multiplied with V. So that is why mathematically electrical power can also be written as the product of potential difference and current. The product of potential difference and current is also called as electrical power. So we know this, right? When you substitute V is equal to IR, you will get power is equal to I square R. When you substitute I is equal to V by R, you get power is equal to V square divided by R. It keeps changing, right? You can use either of them to solve the problems, right? And the next question is, what is going to be the unit of this? So if you observe the unit, work done is measured in joule and time is measured in second. The joule per second is called as watt and it is represented by the symbol capital W. Don't get confused between this W and this W. Here it is work done, there it is a unit of power, it is watt. Okay. That is why when I told you, like you buy a bulb or something, they'll ask you what is the power rating you want. 0-watt bulb, 60-watt bulb, 100-watt bulb, they say, because based on that the brightness will change. Okay, so now you're able to connect those dots. What happens? So this is how it works. Okay, this is all about electrical power. Okay, it's a very simple concept. Make a note of this. LMA parallel, domestic electric circuit is parallel. புரியல எனக்கு. Directly proportional to which one is directly proportional? இது சொல்றேன். ஆமா, v square by r னு வரும்ல. That is mathematically. See, let's think logically. எது parallel connect பண்ணும்? ஒரு டிவைஸ் போச்சுன்னா கூட மற்ற டிவைஸ் அஃபெக்ட் ஆகாது. Okay, that's the simple logic. ஒரே ஒரு Yeah, that is also one of the reasons. நான் இதை பத்தி ஒரு இது பண்ணியிருக்கேன், ஒரு வீடியோ பண்ணியிருக்கேன். எல்இடி ஸ்ட்ரக்சர், எல்இடி சீரீஸ்ல கனெக்ட் பண்ண என்ன ஆகும், பேரலல்ல கனெக்ட் பண்ண. சீரீஸ்ல கனெக்ட் பண்ணா உனக்கு இன்டென்சிட்டி குறையும், பிரைட்னஸ் குறையும். ஏன்னா சரி, அதை கேட்குறேன், அதை எக்ஸ்பிளைன் it. See, let's say I have 360 watt bulbs in my hand. Okay, what do I have? 360 watt bulbs. Now what I'm doing is I'm connecting them across a power source. Right? First I'm connecting them in parallel. Second, I'm connecting them in series. What do you think will happen in each of these cases? What do I have in my hand? 3 bulbs, each of 60 watt. They are first connected in parallel. They are glowing. Second, I'm taking the same system and connecting them in series. There also they are glowing. But what do you think is the difference you'll be able to observe? The brightness in which case will be more. It will be in parallel. Why? Because for the bulb to glow, the important parameter is not the current, it is a potential difference. In parallel, what happens? All the three will have the same potential difference, hence they will glow with the same intensity. Whereas when you take series, right, the potential gets divided, so the brightness will slightly decrease. Are you able to understand? That is one of the reasons maybe everything at our home is connected in parallel. See, that is one of the reasons, but the main reason is not that. Can you tell me why everything is connected in parallel? Not for the intensity, because we are not using only light. If any device gets spoiled also, the other will work independently. Or else what will happen, if one gets spoiled, you need to change the whole thing. You will not even know where to find the fault. The electrician will come, he will break his head. Let's say you have, take this room itself, there are 3 ACs, around 4 to 5 tube lights, no. If anything goes, they don't know where to start the work and where to start the repair. Be a very big headache. Okay, that is the reason why we go in this kind of a format. That's what you would have learned. I'm not sure if, I think that was deleted, domestic electric circuit. Domestic is the household part, like how the connections are connected. Are you able to understand? So did you get an understanding of what the power rating is? Okay, you need not go to shop also, do some window shopping in Amazon. Just go click on some electrical item or fan or tube light, read the description, you will understand half of physics. They'll say a resistance, impedance, they'll use all these words. At what voltage I'm supposed to operate, all those things will be there. So just have a look, maybe let's see if I can show it. You are actually learning science for this reason. வீட்டில் ஏதாவது ரிப்பேர் ஆச்சுன்னா, you do electrical engineering, that's what they will say. ஃபேனை கூட ரிப்பேர் பண்ணதில்லை, நீங்களாம் எலக்ட்ரிக்கல். But that is not the job of an electrical engineer. யார் புரிய வைப்பாங்க? Their job is to design it, not to repair it. That is how our education system is what to do. ஏதாவது சொல்லுங்க, உங்களுக்கு பிடிச்ச ஐட்டம் சொல்லுங்க. என்ன ஏதாவது சொல்லுங்க, சும்மா ஏதாவது பிடிக்கும், என்ன வேணும் தெரியல. இது கூட இவ்வளவு நேரம் யோசிச்சு எப்படி சொல்றேன். என்ன தேடலாம் அமேசான்ல? ஏசி எதுடா? சரி, என்ன ஏசி? ஏதாவது பிராண்ட் ஸ்பெசிஃபிக்? ஃபேன். ஓகே, சரி. டக்குன்னு மறந்துட்டேன். கிராம்ப்டன். டைப் ஆகுதா இல்லையா? Your door air condition. Those who are online are able to see it.
Yes, sir.
Yes, sir.
You brand capacity is 1.5 ton, cooling power 4.74. What is that? இப்பதான்டா படிச்ச வாட்னா பவர் புரியுதா? ஸோ அது ஒரு டைமென்ஷன்ஸ் இருக்கா? ஸோ ஸ்டெபிளைசர் எதுக்கு யூஸ் பண்றோம்? அது எல்லாமே இன்பில்ட்டா இருக்கும். You have to read completely about this. Then you go down and start reading about this, right? You will understand what they speak about dimension. This is all you would have learned in your units and measurements. உருப்படாதெல்லாம் சொல்லி கொடுத்துருப்பாங்க. இதுக்கு தான் நீங்க படிக்கிறீங்க. புரியுதா? டைமென்ஷன்ஸ் தெரியணும். Because when you have a split AC at home, you should understand whether that will fit into that room or not, whether that space has to be utilized properly or not. If you want to buy something, these are all the things you need to think of. தெரியலன்னா you should guide your parents. Correct? So air filter பத்திலாம் கொடுத்து, but this is not a very good example. You can take a simple, because here a lot of alternating current based concepts are also there. Okay, so we can think of, for example, type of that. See, can you do an analysis from here? Brand is there, the color is given, what kind of a fan it is given, powered source, corded electric. Okay, so style is silent pro, even I don't know what it is. So dimensions are given. D na depth in solvanga. This is width and this is height. This is what you learned in your mathematics under the name surface areas and volume. Idam padikkiringa, correct? So where can you use, and all those things are given. This is a remote controlled one. So air circulation, you have something called as noise level. What is this? 52 dB decibels. So 52 dB is the decibel levels. So you're able to hear some sound. So when you switch off everything, if you concentrate on this, you'll be able to hear some noise. So that's something they're trying to talk about. So similarly, you look at the product, no? So sweep, I don't know what is sweeps, I'm sorry. Power consumption only 42 watt. So how this will help is, you are getting your electricity bills, right? This month is something where you have to pay. Pay bill. How many units have come? What units are they speaking about? It is kilowatt hour. So if it is saying that 42 watt is the maximum consumption of it, let's say you are running it for 8 hours, you can calculate how many units it will consume. So the base one, you can multiply and see whether the equipments whether you are getting a genuine bill or not. You can actually do a calculation. Sometimes there will be a miscalculation also. You can fight with people. So if you know science, you're able to understand. So similarly, 315 RPM now, rotations per minute or revolutions per minute. This is again coming under the rotation mechanics concept, right? So air delivery, I don't know what it is. Operating voltage is there, 90 volt to எதுரா சிஎம்எம்னா அது கிடையாதுடா. சென்டிமீட்டருக்கு வந்து ஸ்மால் சிஎம் யூஸ் பண்ணுவோம். சிஎம்எம் இஸ் சம் அதர் அக்ரோனிம். ஓகே, புரியுதா? So like this, you will have many. If you look at light, you will understand things better. So next time observe பண்ணுங்க அதெல்லாம். Okay, on the box itself be given எவ்வளவு இதோட consumption, what is the power rating of it. ஏசிக்கு எவ்வளவு பவர் ரேட்டிங், ஒரு 1 hour ரன் ஆனா எவ்வளவு கரண்ட் ஜெனரேட் ஆகும், or how much will be the electricity bill. You can calculate all those things. Okay, it will be fun also, right? Don't do it too seriously, but do it for fun, right? When I teach you alternating currents, I'll tell you how there is a concept called as power factor. அது எப்படி affect ஆகும் கூட நான் சொல்லி தரேன். அதுக்குள்ள வந்து you need to know about a device called as inductor. அது எல்லாமே உனக்கு இருக்கும். கீழே மீட்டர் போய் பார்த்தீங்கன்னா there will be something called as PF, பவர் ஃபேக்டர்னே ஒன்று இருக்கும். Okay, I'll tell you how to look at all those things. There will be two chapters we are dealing. Now we are dealing with current electricity, right? Here everything we are dealing with is direct current. Never I drew an alternating voltage. அதே மாதிரி 7th chapter is all about alternating current. Complete a contrast curve. That is all. That is the device. Sorry, that is the source on which all these devices are working. I'll explain பண்றேன் அந்த டைம்ல. Okay. So this is all for today. So any other questions? Clear?
No, sir. Yes, sir.
Okay, Ram. Fine.
Thank you, sir.
Thank you, sir.